Bismillahirrahmanirrahim. In this video, we will see how do we analyze earthquake data for any region, for any country. So for this tutorial, I have downloaded earthquake data from USGS website. We have the data in the form of these points, so which is for the whole of my country. And out of all these points, I am only interested in analyzing the points which are present inside this polygon. So how do we clip the data so that only the data which is present inside this polygon is here, and the data that is outside of this polygon is got rid of. So how do we do this? And then we will also see how do we make interpolations for the region that have no data points like this. This is an empty region. It hasn't got any data value, any point value here. So how do we do interpolation so that we can estimate the value of this region and also this region. So I will be doing a nearest neighbor interpolation, or the Voronoi polygon, which is a part of nearest neighbor interpolation. So I have already made a video on how to import CSV files or data points file, separated values file. So for this tutorial, the data which we have is in the form of a CSV file. So first of all, we will be going to import this CSV file. I have already imported the data. So just to show you how do you do that in your QGIS, I will be quickly guiding you. So first of all, you come here and click on this icon which says Open Data Source Manager. Come to this raster option, and again then click on these ellipses. Navigate to the folder where your earthquake data is stored. I have the data here. I will just select this file and click open. Then just instead of raster, we are going to go into delimited text, not raster. Earthquake data is not in the form of raster. Again, navigate to the folder. So this time we have navigated to this folder where our earthquake data is stored. So I have clicked open. In the earthquake data, you can see this is a CSV file. The extension is CSV. I have made a detailed video on explaining whole of this window. So in the file format, you are going to select CSV because it is a CSV file. If it was not a CSV file, you would have selected tab or separated value or colon, space or semicolon. So we already know this is a comma separated value, so we are going with this. And how do you know it is you have selected the correct option? If a table is formed here, then you know that the format which you have selected is the correct one. Or if I select any other option, for example, I have selected tab, and now here the table is no more here, which means the format is not a correct one. So I will go with the CSV format. Then you come here and you see number of headers, lines to discard. How many lines do you want to discard from the data table? If you select zero table, zero lines, so no line will be discarded. All of the lines will be included in your table. The first line here is for this time, latitude, longitude, depth, etc. And if I want to discard one of the rows, so now you can see the first row is no more here, so it means I have discarded one row, but I'm not discarding any rows here, so this is okay. Then you come to this geometry definition, and geometry definition by default the QGIS is taking X field as its longitude and Y field as its latitude, and we already know that latitude and longitude data is present here. If it is not present here, there will be nothing shown here in the X field and in the Y field, and you have to manually select these fields. But as QGIS has already recognized these two options, so I am going with these two. And the Z field, the M field are most of the time optional, but we can select for the Z field depth here, and for the M field magnitude here, which is present in our file. So now we are good to go. I will just click add here, and our data will be added into our canvas. Now you can see data has been added in the form of these points. So there is another very important point you're going to keep in your mind. Whenever you are analyzing earthquake data, you must make sure that your project is in EPSG 3857, and all the layer that you are having in your project should be in the form of in the CRS of 3857. Otherwise, there arises a problem which I'm going to discuss later. If I'm using any other CRS system, so we broadly work in two CRS system. One is this 3857 and the other one is 4326. I was doing it with 4326. It was giving an error when I was clipping these polygon points into my region of interest. So if you're not going to have any error with the 4326, you can go with that too. And but I suggest you go with this 3857. So I have imported these data points into my QGIS project, and you can see this is in 4326. This park map is in 3857, and our polygon is also in 3857. So we need to reproject this layer into 4326. So how do you reproject it? Keep in mind that you are not going to directly change its CRS from here. You change its CRS to 3857. This is not the correct way. Your project, your layer will vanish from the canvas, and you would have no idea where it has gone. So the best way of doing it is that you come here and search for reproject. So you will find reproject layer here, and then you can find this warp reproject. This warp reproject is for raster layers, and this reproject layer is for vector layer. So you double click here and you select the data points. I have selected these data points which are in 4326. You are already seeing them 4326. My target CRS would be this pseudo marketer 3857, EPSG 3857. Share onto this, and a new reprojected layer will be created. This is the reprojected layer which is in 3857. And also notice that the chips which this chips means that the layer is a temporary layer. If you want to make it permanent, you should go ahead and you should right click here, and you must want to save it into a folder. So you just give it a name and save it into a folder. But I have already reprojected this layer into this layer, which I have given a label of EQ data, which means earthquake data. So I'm just going to delete this one, this reprojected layer. I will say Control D, and this will be deleted. I have only this earthquake data which is present, which is for my polygon and outside of this polygon. So first of all, I want to have this data only in my polygon, the polygon which is of our interest, and we want to get rid of all the data that is outside of the boundaries. So how do you do this? You come here and search for clip vector. You can also do it with clip. What the clip does, it combines the polygons with the data points, and whenever you turn off this clip layer, and the points and the polygon both vanish. So we are not going to do a clipping with this algorithm. We are going to do the clipping with this clip vector by mask layer. So just double click here, and you would find the input layer. So for input layer, I have this EQ data which is in 3857, which I have reprojected, and the mask layer, the layer of our interest, which has the polygon. So this is the layer of our interest, our polygon. So just share onto this. Wait a second, and a new layer will be generated here. So this was our polygon of our interest, and this was the data for the whole of my country, but I was only interested in the data that is present inside this polygon. So I will right click here and move this layer to top, uncheck all the other RQ data points, and now you can see these points are only present inside this polygon, and the data which was outside of this polygon is got rid of. We are only interested in this layer. If I turn off this layer, there is no issue that points are still present here. These points are stored in this clipped mask layer. Now we are going to make interpolation for these points. You can clearly see we have data for some regions, for some location, and we have no data for the other locations. So this region is empty, blank, and this is blank. this is also blank. So we want to have interpolation for these points. So there are several options, but for this example I am going with the Voronoi polygons. You come here to geometry tools, vector, and then geometry tools, and you go navigate to the end of the list, and you find here Voronoi polygons. Just click here and select the points, select the layer which is bearing these points. So the clipped layer is bearing these points of our interest. So just select this layer and make no changes anywhere else. So say run to this. Now you can see the, I will just take it down so the points are above them. So you can see all the points Voronoi polygons have been created for these points. So this is how you do interpolation. And still, if you want to get rid of the extra area which is outside of this polygon, of this area of your interest, you can also do that by the same procedure. You just search clip here, and you go to clip vector by mask layer, and you see this layer is have a name of Voronoi polygons. So you select Voronoi polygons here, and you select the mask layer. So the mask layer is our polygon, and you again say run. So now the polygons which were outside of our layer have been deselected, and the polygons which are inside or this layer are now present here. In this video we have learned how do we import earthquake data the correct way, how do we change the CRS of the layers, and I have also told you you must be going with 3857, and all the layers must be in the 3857. And if it is working for you in a 4326, you can also go with this. No problem, there is no issue at all. Now then we have done the clipping, done this interpolation. If you find this video helpful, please give it a thumbs up. And I know you are already going to subscribe to this channel, so enjoy, and assalamu alaikum, goodbye.